Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship SN9. So let's dive right into it. Now, what was this SN9 thing? Well, this supposed to be launched, like it did launch on 2 February 2021, so not that too old, and 3:25 p.m. Eastern Standard Time. Now, this puppy had 3 Raptor engines and the target altitude was 10 km. Now, it had 3 primary goals. Goal number 1, take flight, awesome. Take belly flop, basically demonstrate atmospheric control utilizing flaps, and then land successfully. Now let's understand the flight profile. Profile started with a clean takeoff, everything was awesome, and no issues happened. Then a stable engine shutdown, because you have to understand the rocket is inherently designed to accelerate constantly. It's not designed to go at certain speed. So the only way to achieve that is because the rocket is getting lighter as it's burning through the fuel, it has to turn off engine. So during takeoff, it's starts out the 3, then it starts to turn off 1 and another, then only one engine is needed to achieve that 10 km altitude. Then stable engine shutdown was achieved. Then it caused utilizing cold crash thrusters, belly flop maneuver. Everything was calm, everything is awesome. Its nose was a bit too shallow, but it rectified itself. That's supposed to happen. That was the whole point of atmospheric testing. It's like, can it control itself in the atmosphere? It demonstrated that ability. Everything is awesome. Then it tried to correct itself, and then bad things happened because engine relight kind of failed, and crash and boom happened because of this. Now, what was the fault? Well, at this time of making me, while I'm making the video, there is no conclusive answer. This happened, that's why this happened. And so SpaceX is under no obligation to actually share the information. So fundamentally, we do not know what exactly precisely happened. So at this point in time, we know what led to the fault. That is, belly flop maneuver was completely successful. Then it tried to rectify it. The moment it did that, it tried to fire 2 engines. It did that. One engine came on perfectly. How do we know that? Simply because marked diamonds. You will not get marked diamonds if engine is not running at optimum power levels. The second engine tried, and that's where things went to hell, because that failed, and it just tried to act like a flamethrower. Rather than generating thrust, it was just burning. Now at that point in time, many people are saying they saw a green light in the video clips and all that, is because a lot of people try to capture it utilizing multiple equipment. I have not spotted it, but maybe it's there. And that was the reason. One engine is just not enough power for it to slow down. It was falling too fast, and it simply crashed. And there are 2 reasons why this could have happened, or one of them could have led to another aspect. First, engine fault, because engine was not working properly. It had the stuff, and because it was not as clean green as we used to have, so we know for a fact that it was getting at least oxygen and methane. There is a serious chance it may have gone through void. Void is the biggest issue with turbopumps. If you send a void through turbopump goes boom. There is no salvaging it. You must provide clean fuel. Now in last video when I talked about SN8, I did make a mistake. I assumed the top tank was methane tank. It's not, it's oxygen tank. So to make sure that I don't make that mistake, I will call it propellant tank. Now that propellant tank is supposed to provide fuel. Now if it's providing clean flow, awesome. The moment the flow has void, basically, let's say during the vibration, is a void was created, and then the whole void went through the turbine will be destroyed instantaneously. There is no salvaging it. It has to be a clean flow. And that's why their plumbing is so difficult, because when you're dealing with such a large rocket and you're going to go like this and this, yeah, the fuel flow is very, very difficult beast to manage. And that's what happened. Now, was the engine faulty? There is a good chance that engine itself had a fault, and even though it was getting smooth flow, everything was right, it just blew apart. Or basically there was a plumbing fault that damaged the engine. So these 2 things has happened. We know for a fact that something bad happened, engine went boom and it failed to land. We know that happened. It's just what led to it. Was the engine faulty, or was the plumbing caused engine faulty? So that was the aspect that we know so far. Now one odd thing happened is that you can see this in footage clearly. Things were falling out from the inside. That's not a good look. It's a rocket ship. It's not supposed to be jettisoning parts unless it's designed to do that. It was not designed to do that, and it had debris falling out of it. Now people say that's just thermal matters, but again, those matters supposed to be there. Is engine working condition is supposed to be because if things fall out once it went boom, it does make sense. It's before things went boom, things started to fall apart. That is very concerning, so to say. And that is why this because of the velocity, you can compare this to SN8 almost landed correctly, almost landed. If it had much beefier legs, there would have been a chance that it would have actually nope, I got this, but it did not have strong enough legs, so it went boom. In slow motion it looks almost like it landed, but here it's it did not even manage to rectify itself and crashed, and it lot of energy was released. To give you a context of that, there was a mushroom cloud. That's how powerful this was. So fault happened. Now we just do not know whether plumbing failure happened that led to engine going boom or engine was defective from the start. Now, the reason I'm making this video is like, I'm not that interested into SN development unless they are making big milestones. This was not a milestone. This was like, incremental improvement is the FAA. Now, I did not know this, is that SN8 was not cleared for launch. Now, SpaceX did everything they're supposed to do. They're like, okay, I'm going to file a notice. I'm going to do this. Every paperwork they're supposed to follow, they did that. Only issue was they did not wait it for FAA to confirm back. It's like, I filed a report. It's like, dude, give me clearance. And I launched it. It's like, no, there's supposed to be a step where you like, did you give me the confirmation, yes or no? Go and no go supposed to be granted from FAA. That was bypassed. Now that is very serious. No matter what happens, SpaceX cannot bypass FAA. For this is like the granddaddy system of that. And FAA is not responsible for government or anything like. It's responsible for people's lives. So fundamentally, you cannot sidestep that. It's like, dude, they will give me grant. No, you have to check that. So that created an issue, and that issue was so severe that FAA was forced to do an investigation for safety. Like that's not a oops, no, that's a big issue. Like you cannot sidestep FAA, because if FAA get pissed off like seriously enough, they can simply ground your entire crew. It's like no SpaceX from now. They can do that, and you good luck trying to fight that in a parliament. So they could have done that, but FAA is like, okay bro, this is not a good thing, because the primary reason, like people are saying both parties were doing the right thing, but there was a miscommunication. Now you might be like, how the heck there could be miscommunication could have happened in simple ways. Like SpaceX was thinking that it's just the same thing like how we have Falcon 9, but problem is this is a bigger rocket. It has much more fuel, much more capacity, and because of the sheer size of it, the shrapnel range it can create is much larger. So exclusion zone has to be recalculated. You cannot just send like my assumption is like this. They have to check that. Okay, you are using this kind of propellant, you are using this kind of mass flow rate, this is like how much time you will have in the atmosphere. Like this has to be recomputed, and that's why FAA was taking time, and SpaceX rushed it. That's like nope. That's a flat out no. That's SpaceX was right fundamentally in flaw. You cannot call FAA wrong here, because that's their job. It's like, dude, let me check this. You rushed it, flat out, you are at fault. No matter, again, even if they would have given the green light, you have to follow them first of all. Like that was his thing. And because of the high destruction probability, they kind of provided a penalty. It's like, dude, 10-kilometer penalty. So SpaceX, no matter how badly they want to rush it, they cannot rush this thing. And as of now, as I'm making this video, there has been talks that it has been resolved, but this time SpaceX will be like, be more mindful and be like, okay, FAA, green, go, okay, awesome, then we're gonna do it. If not, no, we'll relax, we'll not rush you. So that's a very important aspect, because SpaceX, while important, while necessary for NASA and all that jazz, if FAA says nope, that's a final nope. You cannot bypass that. So what we can expect in the future at this point in time? Well, for those people who are new to rocket, young people, or people who have not studied other rocket developments, they might find it odd or disturbing. It's like, yeah, it's going boom. It's normal. It's supposed to happen. It's like, if your rocket did not went boom on the launch pad or in the trial runs, something bad is about to happen in your final mission. That happens. It's like, it's a normal thing. Relax is common. To give you a context of that, when F1 engine was being built, it delayed the whole Saturn project by 1 whole year just because of injector plane, because it went boom. So this is normal. This is to be expected. However, for blind fanboys, I would urge you to take time. Like, it takes time. It's a normal thing. It takes time. So those people who are like 2024 it's gonna have moon landing, yeah, that's not happening. Flat out not happening. Best case scenario, they will be able to have a complete system by 2024, which at this point in time I highly doubt it, but they're not gonna get human rating no matter what they do. I mean, like, you need a better example for that. Look at how long once they did the Falcon 9, basically Falcon 9 block 5, and how long it took to prove that block 5, Falcon 9 block 5 is ready, good to go, fast trial run, and to human rating. It takes time. So fundamentally, I do not think, like, there is no way they can achieve that 2024 timeline. That's normal. It used to be expected. Even Saturn 5 took time, so it is to be expected. At this point in time, people are starting to look much more closely to the engine. And in my previous basically SN8 video, I did make a mistake. It's like I said, one engine faulted out in static fire. While that is true, that did happen, but my mistake was the engine was not at fault. Concrete flew into the system, destroying the engine. It was like external fact destroying the engine. That's not engine's fault. So my mistake for that. I'm very sorry for that. But even with that, there are still 3 engine failures. We had first engine failure that coined the term engine rich exhaust, the green fire. That was the first. Second time we did saw SN8 engine going into engine rich exhaust, so that is confirmed. The engine was destroyed, and in this was something bad happened with the engine, so we know for a fact engine was destroyed. So this time that gives us 3 engines that failed in multi-engine configurations. That's not a good look. So what does that mean? That simply means my assumption, be very mindful, I'm very clarifying this is my assumption. Raptor is too close to red line. Like if you are familiar with your motorbikes or car or anything like that, you know all the engines have RPMs and they have like a red zone. It's not that it can't go there, it's just like it's unstable for that. It's like not meant to be stay there. Like you can go there like once in a while, but you're not supposed to, you know, stay there. So I think they're pushing a Raptor to a point where it's constantly in that red line. Now what gives me that you know, confidence to say that? Well, compared to Blue Origin's rocket, which is using the same basically liquid oxygen and liquid methane, same propellant, and has to do similar things, basically reusable rocket, not use and throw. They have much higher paper rating. Like this puppy's paper rating is 40 reuse, that puppy's paper rating is 50. Why the heck it's that higher? Because their PSI, aka their pressure in the chamber, is lower. And I think that's and they specify, like they are not pushing the engine so hard. Now is there a consequence of doing that? Yes, it does reduce your efficiency. Benefit, your engine does not go boom. So I think that we may find out again. SpaceX is dealing with this. I'm pretty sure maybe they just have a one faulty design. It's like they fix that valve. It's like, bro, our engine is awesome. Or they could be like, whoa, we pushed too hard. It's like we have to redesign the engine because it was like just unsustainable. The moment you have multiple engines going YOLO at it, it's like no, I can't handle this. So we do not know. Now just relax. Calm down. The FAA was like a big oopsie on SpaceX part, not on FAA part. SpaceX part is like they have to listen to the granddaddy. But the development process is going to be interesting, and this is the first time we are seeing everything documented in such a high detail. While there are good documentation of F1 engines, good luck finding it. So this was my presentation on SN9. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.